Okay, so I told you yesterday, this is the last really section of new notes that we have to do, and it's all about matrices. So what's today? So there's a few notes today that won't take the whole time, and then we're going to hand out a packet that we're going to work through with some matrix-like questions that will help you understand them a little bit more. We're going to start the packet today, finish it tomorrow, and then maybe the program on Friday. All right, so basically what a matrix is. Some of you have done matrices in math. If you've taken pre-calc, you've seen matrices. It's basically a giant grid of numbers. So like 3, 2, 5, 6, 1, 5, 7, 9, and 4, 8, 0, 3. They still do matrices and trig honors. Yeah, I think Common Core ruined it. Yeah. You'll do them in pre-calc. You did do it? Well, some of them, yeah. Matrices wasn't really a non-Common Core or new Common Core, so it should just be a fun topic in 3 honors. Okay, so basically what a matrix is, you want to think of, some of these are obvious, that's a row, that's a row, that's a row, this is a column, 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 column. And you're going to have to declare matrices and make them a certain size. And the size of matrices is always given rows first and then columns. So rows by columns. So for example, this would be a 3 by 4 matrix. 3 rows by 4 columns. Okay, so in computer, if you want to declare a matrix, explain why it is like this. They're related to arrays, and we'll talk why later on. But if I want to make a matrix, it's int bracket, 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 and then the name of it, like M, equals new int. And then you got to say how many rows, how many columns. So in this case, I'm going to not do one like, this is a new one, 4 by 5. I'll make a 4 by 5 matrix. So this is the number of rows. This is the number of columns. So this isn't the same matrix that I have written up above. New example. And the reason it's kind of like an array is because it's really an array of an array. So if you can picture, we've had integer arrays, we've had double arrays, you could do string arrays, you could do Boolean arrays. Now we're doing array arrays. So that means every spot holds another array. The result is you've got this big matrix. So it's still the same idea as an array where you've got M is some memory location. It's called a pointer. And it's pointing somewhere in the computer where this is stored. And this isn't necessarily how the computer thinks of it. I'll show you how the computer thinks of it in a second. But this is how you want to visualize it. You want to visualize 4 rows. They'd be numbered 0, 1, 2, 3. And then you want 5 columns. They'd be 0, 1, 2, 3, 4, 5. Yeah, just kidding. 0, 1, 2, 3, 4. And if you don't initialize it with an initializer list, then initially in a matrix, this matrix, since it's an integer matrix, is filled with all zeros. Again, we call this a 4 by 5 matrix. There's 4 rows by 5 columns. If you want to know how many rows are in a matrix, so number of rows, you could say int num rows equals m dot length. Which is really just like an array. So I said a matrix is really an array of arrays. So the original array is the number of rows. So 0, 1, 2, 3, that's your initial array. Then if I want the number of columns, each spot in the array holds another array. The length of that second array is the number of columns there are. So you could say int num row or num columns equals m bracket 0 dot length. And if you think about it, that should make sense. If it really is an array of arrays, then m bracket 0 is another array, so I can take the length of that one, and that's how many columns there are. Now I use bracket 0. For this example, I get the number of columns if I did m bracket 0, m bracket 1, m bracket 2, or m bracket 3. We can put any valid row number here. And it will still work. We usually use 0 because there's always going to be a row 0. If there's an array at all, there's definitely a row 0. If I want to access a certain spot in an array, let's say I wanted to make, say I'm going to make this spot right here, I want to make that a 5. Then I would say m bracket 1 bracket 3 equals 5. So M matrix, row 1, column 3, it's going to be 5. If I wanted to make this spot here 10, what would I do? M bracket 3 bracket 2, row 3, column 2 is equal to 10. Any questions yet? Okay. I'm going to declare another array, and this time I'm going to try to show you a little bit more of how the computer is actually thinking of it. So this time I'm going to make a 4 by 3 array. So int bracket m equals new int 4, 3. So again, you should visualize 4 rows, 3 columns. So this is you over here. You're picturing 4 rows, 3 columns. So 0 through 3, 0 through 2. What the computer's doing is it's setting m equal to a memory location. It's sending it off to some array. And its array that it's sending it to has 4 spaces. And then it's an array of arrays. Each of those 4 spots holds another array that has 3 spots in it. And those spots would be labeled 0, 1, 2. 0, 1, 2. And all of them. So you can kind of see why it's making sense when I say M bracket 1 bracket 3, it's going to spot 1 in the array, and then in that case it was column 3, but there is no column 3 here, but whatever spot within that spot. So if I said right now, go to M bracket 2 bracket 1 and set it equal to 5, and it would go to my M array, go to spot 2, and then spot 1 in that spot, and set it equal to 5 right here. Okay, now if I get really technical, just kind of show you how this really fits an array. That outer array is really just holding pointers to more arrays. So this outer array, I'm going to list it down instead of horizontally this time. This is that same outer array, black one from before. Each space here, M bracket 0, is a pointer to another array of size 3. And this is a pointer to another array. And each of these, if I color code it the same I did up there, this would be that inner array. That would be that inner array. That would be. So you can see in the end, my result is 3 columns by 4 rows, and that's why it's a grid of numbers. All right, so that's what the computer is actually creating. That's how it's doing it. But again, anytime you're working with matrices, you should really just think of that big grid. That's what you want to picture. Any questions now? Okay. Last part of your own notes, then we'll do some questions relating to arrays over there. I'm going to show you how to make a method with an array in it. So write a method. That creates a multiplication table. What a multiplication table is, if you can like picture your 3rd grade room and probably look in one of the corners and there's a big poster up that has a table of values, you know, like 4 times 9 is, and you look down there and it says 36. That's what I'm talking about. So multiplication table, each element of the matrix is the product of its row and column. So no matter how big the matrix is, let's say it's just, as an example, just a 3 by 3. So if this was my matrix, I would want this to be filled with 0 times 0, 0 times 1, 0 times 2, 1 times 0, 1 times 1, 1 times 2, 2 times 0, 2 times 1, 2 times 2. So that's what I'm trying to get. All right, so I'm going to make an actual method out of it. So public void. When you're filling a matrix, just like filling an array, it's still a public void. Public void multi table. And if I'm sending it a matrix, then it would say int bracket 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 m. Precondition would be an integer matrix. And postcondition would be fills the matrix as a multiplication table. Okay, so if I'm going through a matrix, I have to go through all the rows and I have to go through all the columns. In order to do that, we need a for loop within a for loop. So the outer for loop, I usually start by going through all the rows. It doesn't really matter. But if I start with going through the rows, for int I equals 0, I would just say I is less than m dot length, I plus plus. So that goes through the rows. And it's not enough just to go through the rows. I have to go through each spot in every row. So I got to go through every column also. So then I have another for loop inside it, and I can't use I again, so I have to use a different variable. So anytime you have a for loop within a for loop, it needs a new variable. So let's call this int j equals 0. And if I want to go through all the columns, that's when I do j is less than m bracket 0 dot length. J plus plus. That's going through the columns. Again, if you think about it for a second, hopefully that makes sense. If you look at that example I did up here, if I want to go through all the rows, that's just the original m dot length, how many rows I've got. And if I want to go through all the columns, I have to access one of those spots and see how many columns they have. So m bracket 0 dot length would be the number of columns. And I use bracket 0 here. I could use bracket anything I want. Sometimes you don't have to write this. But sometimes you'll see people writing m bracket I here. That's still definitely going to be a valid row because if I'm down here, I goes through all the rows. So that would also do it. M bracket 0 works just as well though. And I want each spot to equal the column, the row times the column. So I'm just going to say m bracket I bracket j would equal what? Just I times j. Row times column. That's it. All right, so next we're going to go through a couple questions in this packet that I'm going to hand out. We're only going to do the first page today. We'll finish it up tomorrow. Those watching at home, I'm going to pause you for a second. Okay, so this packet, if you weren't in class today, you don't have this packet, but you can download it off my website if you'd like. I'll talk to the people at home. But we're going to go through this today and tomorrow. First one. These are all AP questions dealing with matrices. Which of the following initializes an 8 by 10 matrix with integer values that are perfect squares? Remembering 0 is a perfect square. Think about this one for a second, and then we'll talk about it. So see what you think it is. All right, so here it is. First one, int bracket mat equals new int 8 by 10. They're all 8 by 10, so the size is all right. If I don't do anything with the matrix, would that make everything initialized to perfect squares? Yes, because they'd all be 0. Right. So all 0, so number 1 is definitely good. So it's definitely not 2, it's not 3. Those are out. All right, second one. Make a matrix. 4, int r equals 0, r is less than mat dot length. Is this going through the rows or the columns there? Rows. They actually used r, they meant it too, so that's nice. And the second one, int c equals 0. C is less than mat bracket r dot length. That's going through all the columns. Is it okay to say bracket r here? Yes, because r's are all the rows, 0, 1, 2, up to 7. So that's okay here. Then it's setting those equal to r times r, which would be a perfect square. Now what might look a little weird here is that there's no brackets. That's okay. And that's kind of a shorthand that some people use. As long as there's only one thing inside each, one line of code underneath, then it's okay to not put brackets. So in this first for loop, this is technically one line of code. It's one for loop underneath it. So that's why this doesn't need brackets. So 2 definitely works. So now A is out. 3 makes a matrix Now it says C equals 0, C is less than mat bracket R dot length. What's that going through? Columns. And then R equals 0, R is less than mat dot length. So now I'm going through the columns and rows. Am I still going to hit everything if I go all the rows by all the columns, or if I go all the columns by all the rows? Yes. So can I do this? No. You can do columns before rows. You'd still hit everything. There's just something wrong with the way they wrote it, Spencer. It's right. You're using R here, but when does R get initialized? After it. So you get one of those little R has not been initialized things. If they change that, if they wrote mat bracket 0 dot length, that would all be totally fine. But since they used R there, 3 doesn't work. So it's D. And that's why the APs are jerks. They do things like that. They also like doing things like putting less than instead of less than or equal to, like question 1 on the test yesterday. Which messes up the answer to question 1. Next question. Consider the following method that will alter the matrix max. Public static void max stuff. So I'm sending in a matrix, and I'm sending in a row. Sets nums columns equal to mat bracket 0 dot length. So is that really the correct number of columns? Is that doing that correctly? Yes. So this is the number of columns. Then it says 4 int column equals 0. Column is less than num cols, col plus plus. Setting mat bracket row bracket column equal to row. Now row is getting sent over. Row is a parameter, so row is not changing. Column is, because column's going through the for loop. All right, then they were nice to you. They gave you something to start with. They said, suppose mat is originally this. If I call mat stuff, sending it this mat matrix, and 2, so for my example, row equals 2, what will matrix mat be? See if you can figure this one out. Okay, so for this one, remember how a matrix is actually numbered. This is row 0, row 1, row 2. This is column 0, 1, 2, 3. So if I send it 2 for row, and row never changes, this is always mat bracket 2 bracket something is equal to 2. For loops taking you from column 0 and less than column length. So it's going to take you 0, 1, 2, 3. So it's setting only row 2, but every column in row 2 equal to the number 2. So the answer is A, because row is never changing, only column is. Any questions? Okay, said we were going to stop there, but let's keep going. Number 33. We'll stop after this one, promise. Assume that a square matrix mat is defined by int bracket 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 mat equals new int size size. So it's same rows and columns. They give you a following code segment. So they go through i's, j's, can assume they're rows and columns probably. And it's doing this swap thing. It's sending matrix I and j with size minus j minus 1 and size minus I minus 1. It's kind of confusing right now. It says you may assume the existence of this swap method. So public void swap, when I send it a matrix, and it swaps what's in the first row column with what's in the second row column. Okay, so when I'm looking through all of my choices here, the thing that makes this question difficult is that we don't know what size is. It's all ambiguous. But if you look at your examples, they're all the same size. So I'm going to say here, note, these are all 2 by 2. So size, we can assume size equals 2 for what we care about. So when I make a matrix, everything up here that says size, I can think of as 2. So the for loop's going to run while I is 0 and while I is less than 2 minus 1, which is 1. And then j is going to run while j is 0, and then j is less than size minus I minus 1. What values are I going to be allowed to be? Just 0, right? It's got to be less than 1. So I's only going to, the outer for loop's only going to run one time when I is 0. The inner for loop will run while j is less than 2 minus I minus 1. Well, if I is always 0, 2 minus 0 minus 1 is also 1. So j is also only going to be 0. So this is only going to happen one time, and all it's going to do is it's going to swap matrix 0, 0, size minus j minus 1 would be size minus 0, or 2 minus 0 minus 1, so that'd be 1. And 2 minus I minus 1 would also be 2 minus 0 minus 1, so also 1. So even though this is a tricky setup, based off of the questions, only one thing's happening, and it's swap 0, 0 with 1, 1. So which of your choices down here is swapping 0, 0 with 1, 1? And only swapping 0, 0 with 1, 1. B. 0, 0 is this number. 1, 1 is this number. Here they're swapped, and nothing else changed. So that's the only one that swaps just those two values. So it's B. All right, so hold on to that. Tomorrow we'll finish this packet, and if we go quick enough, maybe I'll also hand out the program tomorrow so that those of you who are taking AP English on Friday or AP US on Friday will have that.